Herstein's Abstract Algebra 3rd edition, Chapter 2, Section 1, Problem 1F. Determine if the following sets G with the operation indicated form a group. If not, point out which of the group axioms fail. So our set here is going to be any set with multiple elements, and our operation is A star B equals A. The question's asking us to do is look at the four axioms of a group: closed, associative, identity element, and inverse, and check if they hold or not. If all four hold, this is a group. If one or more of them fails, this is not a group. So let's check condition 1. Is G closed? The closed condition, the easiest way to think about it is if I take any two members of the set and apply the operation star, does star return a member of the set? Here it clearly does. It doesn't matter which two elements of the set you give me, it's going to return the first one, right? A star B equals A. Well, A and B are members of the group, so A certainly is, and A star B equals A, so this group is closed. Moving on to our second condition, associative. Are these two equations equal? The only difference in the two equations is that the order in which we apply star. So in the first equation, we do A star B first. A star B equals A, because A is the first element of those two. And then we do A star C, and we get A. In addition, on the second equation, we're going to do B star C first. B is the left-hand element, so B star C equals B. But then when we do A star B, we get A, which is equal to our first equation. So we conclude that axiom 2 is satisfied. Now for the third, we're looking for an identity element. An identity element is a member of the set such that, and here we indicate it by E, such that E star A equals A for any A in the group, and A star E equals A for any A in the group. And here we run into a problem. So let's look at the first equation, E star A equals A. E star A on the left-hand side, E is the first or the left-hand element in the operation, so we conclude that E has to equal A. Right now we're very suspicious. Remember, A is any element of this group. So our identity element should not depend on which element we picked, right? But let's keep going. A star E equals A. Well, here, A equals A is our conclusion. So that doesn't really give us too much information. But what we conclude from these first two equations is that E has to equal A. What happens if we did this for another member of the group, though? So we know that this set has multiple elements. So let's just pick one, B in G. We must have, for condition 3 to hold, E star B equals B. But we know that E is equal to A, or at least it has to be in order for this condition to hold. That would mean that A star B equals B. It doesn't work. And here we highlight that E star B equals A star B, which equals A, and that doesn't equal B. So our suspicions were correct, right? We were suspicious when the identity element depended on which element you gave me, and then we just found a quick counterexample here that E star B does not equal B. So we conclude that there's no identity element, and condition 3 fails. Condition 4 depends on condition 3. In order for there to be an inverse condition, we need an identity element from part 3. We didn't find an identity element in part 3, so 4 automatically fails, and we conclude that G, star is not a group because it fails both condition 3 and condition 4.